My name is Professor Tim Stevens. I'm a Professor of International Law at the University of Sydney Law School, and it's my absolute pleasure to be chairing the Australian Centre for Climate and Environmental Law 2021 Distinguished Speakers Address. And our speakers will be addressing this most important existential question, which is whether or not climate litigation can save the planet. And specifically, our speakers will be looking at the role of climate attribution science. I've worked in this area for some time, and it's very exciting to see how scientific developments are allowing us now to sheet home responsibility to states and perhaps even to individual polluters for some of the extreme weather that we are experiencing. Before we get into the substance of the lecture, it is also a great pleasure to welcome, to invite Yvonne Weldon, Wiradjuri woman and elected councillor on the City of Sydney Council. According to the ABC, I just checked the results, she's just been elected. Yvonne has very kindly agreed to do the welcome to the special country that we're all on. Yvonne.
Thank you, Tim. Hello, ladies and gentlemen, sisters and brothers. I stand before you on the land of Eora. I've grown physically on this land, but in my blood and always in spirit, I am Wiradjuri. As was said, my name is Yvonne Weldon, and I'm a sovereign woman. I come from Cowra here in New South Wales, from the waters of the Clare, which later became known as the Lachlan, and of the Murrumbidgee rivers. I am the elected Deputy Chairperson of the Metropolitan Local Aboriginal Land Council, who are the cultural authority under the Aboriginal Land Rights Act for the land I am on. I'd like to pay my respects to all elders past and present, to all First Nations, to you and the ancestors' lands that you are on. A welcome to country is an age-old tradition. It is more than just words, it is a spiritual process by honouring the ancestors' footsteps we are all walking in, continuing the practice of the generations before us to the many generations to come. The boundaries of the traditional owners are written into the Earth's natural landscapes. The boundaries of the Eora are the Hawkesbury River in the north, the Nepean in the west, and the Georges River in the south. On behalf of the Metropolitan Local Aboriginal Land Council, the elders, and the members, I welcome everyone to the land of the Gadigal. I acknowledge the Gadigal people and also the people of the lands that you're on today, whose spirits and ancestors will always remain with these lands, our Mother Earth. Across this beautiful continent, there are hundreds of nations, tribes, and clans that have existed here for over 60,000 years. This country's First Nations people are the oldest living culture of the world. And as we're all joined online, let us all remember and acknowledge the many warriors that created pathways for all of us, the ones recognised and the ones we've never heard of. My people have always listened and learnt from each other, the environment, animals, elements, and our ancestors. We don't live in isolation of body, culture, spirit, land and water, because we are one, for in our blood it runs. We need to reflect upon the footsteps we're leaving to know where we're heading, shaping a society, a country, a world we can be proud of. All of us together can bring about positive changes to multiple generations, starting a healing to the past generations by declaring what should not have taken place, to the present day generations, giving them hope and creating a future for the next generations, for everyone in this country. We are in this together and we can achieve positive change each and every day, bringing my people, your people, and all our people together. As you consider and listen to the views being presented today and our impacts on our globe, on our global impact and the climate risks that take place, make sure that you are the voice for the world and for the land and for our oceans and for our rivers and all of that consists in our beautiful world, to make sure that they have voices, because if we don't speak out, we may never have that change that needs to take place because of what should not have taken place. Remember to reflect about my people's stories and our connection to the land, that were forever raised and changed when we were erased from the view. My people lived in unison with this country for thousands of generations. Learn from our ancient practices because we are still here. And think about the difference you can make today that will become the milestones of the future, all our futures. So let us all draw upon my people's spirits as we continue on our journey. May my people's spirits walk with you and guide you as we strive forward for us all. Again, on behalf of the Matchbong Local Aboriginal Land Council, welcome to Gadigal land. This always was, always will be Aboriginal land. Thank you and have a wonderful day.
That's wonderful. Thank you so much, Yvonne, for that really generous welcome to this beautiful country. So it's my great pleasure to introduce our two speakers, both of whom are joining us from the United Kingdom very early in the morning and getting organised for the day and sending kids off to school and so on. So thank you so much to both of you. So we're going to hear first from Dr. Friederike Otto and then from Dr. Petra Minnerop. So first, Dr. Friederike Otto, Freddie to her friends. She's an honorary research associate of the Environmental Change Institute at the University of Oxford and an associate professor in the Global Climate Science program. Freddie leads several projects understanding the impacts of human-induced climate change on natural and social systems with a particular focus on Africa and India. She's the co-lead of a tremendous initiative called the World Weather Attribution Project, which is an international effort to analyse and communicate the influence of climate change on various extreme weather events. In 2019, Freddie was named one of New Scientist's Ones to Watch, and in 2020, the WWA was named well, I should say, climate change attribution was named as the one of the MIT Tech Review's top 10 breakthrough technologies. And in 2020, Freddie became one of just 10 climate scientists to join the core writing team of the IPCC synthesis report for the 6th assessment report. Freddie will be speaking first, addressing where we are up to in terms of climate science attribution, which is a very exciting field. We'll then have a short period of time for questions, and then we'll turn to Dr. Petra Minnerop. Petra is an associate professor of international law at Durham University, and you can see Durham in the background. That's right, isn't it, Petra? And she's also the university's academic lead for COP26, or was the university academic lead for COP26, and co-director of the Global Policy Institute and co-director of the Research Centre for Law and Global Justice. Prior to joining Durham, Petra held senior academic positions at various universities, including Dundee, Munich, and she worked as a senior research fellow at the Max Planck Institute for Comparative Public Law and International Law in Heidelberg. And she's also a member of the bar in Germany. So welcome to you, Petra, as well. So first of all, we'll turn to Dr. Otto. So yeah, Dr. Otto will address us for 30 minutes or so. We'll then have some period for questions. And can I just indicate that questions will be taken via the chat feature on Zoom. And we'll enable that feature when the Q&A period begins. So start thinking of good questions to ask and pop them down there, and I'll pull out as many as we can and see if we can address them. So over to you, Dr. Otto.
Yeah, thank you very much. Thank you very much in particular to Yvonne for the warm welcome to Australia, even though it's just virtually for me, sadly. I'm actually not in Oxford anymore. I have started a new position at the Grantham Institute at Imperial College in London, but I'm still, of course, working on the attribution of extreme weather events to climate change. So I would like to start with this, as Tim has said earlier, slightly terrifying picture, that to remind us all that we are long in the era of loss and damage, especially when talking at COP and other and other climate policy discussions, climate change is often talked about as the problem of the future. And especially when we talk about the climate goals that we have agreed to in the Paris Agreement, 1.5 degrees or 2 degrees, quite often it is talked about as if there is this magic number. If we stick to constraining temperature rises to 1.5 degrees, then everything is fine. And after 1.5 degrees, suddenly a bomb explodes and everything will become a disaster. That is, of course, not how climate change works. And we have already 1.2 degrees of global warming. So 1.2 degrees warm, 1.2 degree warmer world than at the beginning of the Industrial Revolution. And this 1.2 degree warmer world manifests in the changing intensity and likelihood of extreme weather events in raised sea level rise. And we pay for this with lost lives, livelihoods, and of course also large economic costs. And it is those in our societies that are most vulnerable who are currently paying this. And this is what has been sort of captured under the term loss and damage in policy negotiations. But it is these climate change impacts are how we experience climate change today, and how climate change manifests and will continue to manifest with increasing temperatures. So with 1.5 degrees, we will have more changes in extremes, but they will be gradually more than at 1.4 degrees, and they will be gradually worse at 1.6 degrees. So it is important, of course, crucially important to constrain future temperature rise, but we cannot do that while completely forgetting all the changes that have already occurred and that will occur in the future, in the next years, until we reach these goals. So, to continue, how do we actually know this? How do we know whether the changes in extreme events or the extreme events that we see are due to man-made climate change? We know this by using a science called event attribution. And in this event attribution, the main aim of that science is to disentangle the drivers of extreme event. So what is natural variability? What is human-caused climate change? What are other drivers like land use changes and so on? And this science has been around, well, theoretically, it has been around since the year 2004, when the first paper using that kind of approach has been published, but it really only has been applied on a larger scale since since 2012, 2013. And so since then, we now have a very large number of studies looking at whether and to what extent human-caused climate change has altered the likelihood and intensity of extreme weather events. And for the first time, this science has this year, or well, in the years before, but this year it has been published, been assessed in an IPCC assessment report. And what you can see here on this hexagon schematic map is the result of this assessment for heat extremes. So every red hexagon shows where in the world, in which region, a region in the world where we do see a significant increase in hot extremes, and that includes heat waves, longer, hotter, and more frequent heat waves. And you see underneath the abbreviation of the name of the region, you see a number of dots. And these dots indicate how much confidence do we have in our assessment of the role of human influence in these observed changes. And you can see that for most parts of the world, there are 3 dots, which is the highest category. So we not only observe these changes, which we have done, of course, for a very long time, but now we can actually, on a regional scale, attribute these changes to human-caused climate change. But of course, heat extremes are not the only extreme event that affect people. So this is the second part of that figure, which shows the same idea, but for heavy rainfall. And here you can see in green these the parts of the world where we do see an increase in the likelihood and intensity of heavy rainfall events. And again, the dots represent the confidence in attribution. And what you can immediately see here is that while we do have a lot of evidence for the role of observed changes and the role of climate change in Northern Europe, in parts of North America, in large parts of Asia. But there are a lot of parts of this map where the hexagons are gray. And gray hexagons are those parts of the world where we do not have enough academic literature to actually make a meaningful assessment in the IPCC report. So of course, that doesn't mean that no heavy rainfall events happen in large parts of Africa or also in Central or Southern Australia, but we just don't have academic studies that look at these heavy rainfall events, and particularly looking at what's the role of human-caused climate change. And that is showing that there is, and the IPCC report, of course, its mandate is to assess the academic literature. So the IPCC doesn't do its own science. So what is not published in the literature cannot enter in the IPCC report. And so therefore, this map really shows that there are crucial and very important gaps in our current understanding of how extreme weather events are affecting a large part of the world today. And when we see it, the last part of this picture is for droughts, and there we have more evidence because there are a lot fewer of the gray hexagons, so which are the areas where we just don't have enough data and literature to make any assessment, so where we in effect have no idea what's going on these scales. But you can see here a lot of these white stripy hexagons, and these show areas where on the scale of these regions, and that is really important to understand these IPCC figures, because the assessment is made on the scale of the region, which is, so there are 52 hexagons in total. And of course, if you divide the world in 52 regions, that's still very large region. So a lot of things are happening on scales that are much smaller than these regions. All our decisions on adaptation, on loss and damage, and also a lot of weather events, of course, happen on much smaller scales. And so when you see these stripy hexagons, that means that there is no change in the likelihood of drought in this case at the scale of this large region. But that doesn't mean that on a smaller scale, there is no change in some of the extreme events. But of course, it also means that not highlights the fact that, of course, we have known for a long time, but which is now for the first time really globally assessed, that climate change is not affecting all extreme weather events across the world in the same way. So I spent a lot of time on this IPCC figure, but I think this is really important because the IPCC science is not just the same as another scientific paper or an NGO report, but it is really a sort of meta sort of evidence because it is consistent of an assessment of all the academic literature that exists on a particular topic, and therefore has a lot more it has a lot more bearing, and probably also in courts, definitely in from a scientific point of view. So where we have strong, high confidence in the IPCC, we have really high confidence in the world, because by its very nature, the IPCC is very conservative, because it has to take all parts of the literature into account, and also papers that have come to different conclusions and that might not be, and make an assessment of which aspect of literature really have found out something, have created facts and new knowledge. And therefore, understanding what this actually means is, I think, really important if we want to take this science outside of the scientific realm into the real world and make decisions with it and take it into the courts. So the second part of this talk, I will now very briefly go into how do we actually know this, and how do we actually come to these conclusions that have been assessed there. And the idea behind event attribution is really pretty straightforward. So what we do is we use observations and statistical modeling and climate models, which are in effect the same models as used in weather forecasts, and simulate what is possible weather in the world we live in today. And then based on extreme events that have happened and the impacts they have caused, we can then define a type of event or a particular event that we are interested in as the extreme event. And so it might be that a temperature in Sydney above a certain threshold in January lead to huge increase in mortality. So that's what we use as our event definition for an extreme event, as the threshold here in this figure. And then we can figure out what's the likelihood of that event to occur in the world we live in today with 1.2 degrees warmer climate. And it might be that it's a 1 in 10-year event. And then we do the same thing in the world without climate change. And we can do that because we know very well how many greenhouse gases have been put into the atmosphere since the beginning of the Industrial Revolution. And so we can simulate the world that might have been without climate change. And in this schematic, you can see that the possible weather in that world looks very different. And so the likelihood of such an event to occur in that world is smaller. And if that's the case, then we can attribute the difference in the occurrence frequency of these events to man-made climate change, because that's the only difference in these two worlds. But it's really important to recognize that it doesn't mean, so the question was this, the question that the media often asks is, was this climate change or not? This is not the right question, because all extreme weather events always have multiple causes, and climate change can be one driver. And it can be a very important driver. So one study we have done this year was for the heat wave in Canada and northwestern US, where temperatures reached almost 50 degrees in Canada. And that was an event that was that would have been almost impossible to occur without climate change, because climate change made it from an event that we would expect to see maybe once in 80 million years or so, which is the statistical equivalent of never, to an event that is still a rare event. So it's a 1 in 1,000-year event, but it's an event that we have witnessed and that we have also to calculate with. But this is really not the case for all extreme events. Another event that we have looked at this year and that has also made many sad headlines is the drought in southern Madagascar that is still ongoing, where 2 years in a row the rainy season was very bad and had only 60% of average rainfall, which led to drought. And because of the very, very high vulnerability of the population in that part of Madagascar, led to severe famine-like conditions. But this event is not one where climate change was a major driver. So it didn't change the likelihood of such a failure of the rainy season very much. But of course, that doesn't mean that we shouldn't care about this event, and that it also doesn't mean that climate change is not important in Madagascar. It is just not the driver of every type of extreme weather event. But the very, very high levels of vulnerability mean that in this part of the world, even we are even not adapted to the natural variability of today's climate, let alone a future changing climate. And this is also a really important aspect that we can find out with these attribution studies, which is really important though when you try and go to court using impacts of different types of extreme events, because climate change is often perceived as a driver whenever something bad happens, but it's just not always the case. And we know with this science of attribution that has been, as I said, around on a significant scale for a bit less than 10 years, we have looked at many different types of extreme events in many different parts of the world. But of course, there's still a huge gap between what we know and what is actually happening and has impacts in the real world. And this is what I've tried to illustrate on this map. So what you can see here in red, in these red circles, are deaths associated with extreme weather events that have happened over the time span where extreme event attribution was around. And the larger the circle, the more death associated with extreme weather events. And overlaying this in black are those deaths associated with extreme weather events for which we do know the role of climate change. So it doesn't mean that all the black deaths are associated to climate change, but we have scientific evidence and scientific understanding of what the role of climate change is. And there you see what was also evident in the IPCC figures I showed earlier, that we have this huge discrepancy between the global south and the global north in terms of the availability of scientific evidence, because you see that in Europe and also for Australia, we have the size of the circles almost the same, which means that for most, at least for most of the deadly extreme events, we do understand the role of climate change, but for many parts of the world, we don't have that. And it's so that where people are most vulnerable, we have the least understanding and the least science available. So this means we have now tools and methodologies to undertake something like that you can call an inventory of the impacts of human-caused climate change. And I don't want to go into details in this figure. If you're interested, you can look at the paper. But we don't have such an inventory yet. There is no global database where you can see extreme events and their attribution. So the IPCC figures sort of give an overview, but only, of course, on these very large regions. But we could do this because most countries do have an overview of what extremes happened and what the impacts were in that country, and that could be combined with scientific literature. But it is not done yet, neither on a country level nor on a global level. So if we want to bring together impacts of climate change and extreme weather events and damages with the scientific literature, there needs to be an extra step taken. So it's not something that you can just take from somewhere, but it is something where you actually, at this point in time, you need to write a scientific paper or bring the pieces of evidence together. So to finish, I would just like to say two things of why I think this is really important. So one is this year's COP had some crucial, really weak outcomes, and they were in particular with respect to loss and damage. So climate justice was talked about a lot, and it was throughout the 2 weeks. But in the end, actually, loss and damage was just postponed again to the next COP in real terms, and also the climate finance that was at some point promised in that was not really did not end up as strong as most people had hoped for in the end. And what I found particularly noticeable is that people, especially Europeans, talking about climate justice, always talked about intergenerational justice, but seem to forget that there is also international justice and justice between the global North and the global South that we cannot forget. And so, yeah, I would leave it at this and let Petra talk about the legal aspects of this and how and where this science has been used in courts, not very much, and not necessarily in the best way it could be. Thank you.
That was tremendous, Dr. Otto. Thank you for making highly technical and challenging areas of science very accessible and understandable, even for a Luddite like me. That's very, very helpful. And I can see lots of different connections, and we're about to explore them with some of the legal issues. And can I also just take a moment to acknowledge the point that you made about the authority that the IPCC work carries. I think that point is extremely well made. It's not just another scientific paper. It's extraordinarily detailed, comprehensive, thorough and conservative assessment of where the science currently stands. And as we know, the IPCC work has improved in successive assessment reports. Okay, so we're now going to have around 10 minutes or so for questions before we then move on to our second speaker. So the chat box is now open. If questioners want to pop in their questions, I'll moderate the questions. So I'll pull out those that I think we can deal with. So, all right. So the first one. Okay, first question from Craig Longman. A question, I don't know whether you can see this, Freddie, asking whether you think there's value in having litigators and scientists working together to identify where further research is needed for successful litigation to build an evidence base for potential novel legal arguments. Great question.
Yeah, and I think it's not only I think it's not only there's not only value in having that. I think it's really crucial because at the moment we have actually a student of mine led a study that Petra and I both worked on, where we looked at the state of what scientific evidence in this space is brought into courts, looking at 80 current and past cases, and found that in most cases, the scientific evidence that was actually brought to courts was far behind the state of the art of current science. And so while these cases largely have failed on other things than the scientific evidence, it certainly didn't help them that the scientific evidence was not, and if they had not failed on procedural things, it might have become a real problem. And so that, I think, was a huge indicator that we need to work together on the one hand so that litigators can understand what actually the science can and cannot say, but also so that we scientists can understand of what aspects of the science or how are actually the questions asked in court, so that we can frame answers that or our research so that it can actually address these questions, which at the moment is also not really the case. So yes, I think it would be very, very, very valuable to move this space forward.
Very good. Now the next question we have is a very specific one from Steve, asking around or what confidence we can currently have in attribution science when it comes to wildfires, or bushfires as we call them in Australia. And this is obviously a big issue in Australia, especially given the terrible summer of 2019 and 2020, the Black Summer, which was unprecedented in Australian history?
Yeah, so I think as a rule of thumb, the more complex the event, the lower the confidence. But for wildfires, we actually have comparatively high confidence, because fire weather, as you in Australia probably know much better than I do, consists of several aspects. So there are the high temperatures, but then also the low relative humidity and the high winds. And in all the and there have been quite a few attribution studies on wildfires, including the one on the bushfires in Australia in 2019, 2020. We found that while humidity, wind does not change very much, at least hasn't changed very much up till now because of climate change, the temperatures have increased quite dramatically. And so that means that almost everywhere, the likelihood and intensity of wildfires does increase because of climate change. And so the confidence in that aspect is pretty high, because it is driven so much by the temperature increase, which is one of the aspects of climate change we really understand well.
Okay, I can't see any other questions in the chat box. We just had a thanks from Steve. Thank you, Steve, for being so polite. So if we don't have any further questions, perhaps people can think through additional things they want to ask. They won't be able to ask Dr. Otto. She has to leave us, but we will have Petra available to deal with some questions. Oh, there's a good question from Morgan. I think, Morgan, your question will go nicely to Petra, so I'll save that up for the final Q&A. So at this stage, I want to thank very much Dr. Otto for her stimulating, interesting, terrifying presentation. Thank you for getting up so early in the morning to do this for us. It's really greatly appreciated. And I'll now hand over to Dr. Minnerop, who'll take us to the next segment of this lecture.
Yeah, thank you very much. Thank you very much for inviting me here today to be part of this series. It's a great honor and privilege to be here. But of course, as Freddie said, we would much rather like to be in Sydney with you. And thank you also for the very warm welcome of Mrs. Weldon. It's very much appreciated, and a great introduction to our topic, I think. And Freddie, thank you for setting the scene again. I always like looking at your slides. They're so very informative. I will try now to share my slides with you to add some legal content. Go to the beginning. Can you see my slides? Okay. Yeah. So now the overview, or the way I would like to guide you through these slides, is in three main parts. I would firstly look into some of the cases that we have seen so far in more recent years, where we can perhaps derive some tendencies in terms of how courts are using some of the science, and how they then find causal connections between climate drivers and climate change impacts. That will be the first part. And then the second part will look into the work that I've done with Freddie and others, as she has already indicated, on using this potential of attribution science for legal concepts to make causal explanations in the law, and also to attribute even specific impacts of climate change to certain emitting regions or to certain emitters. And on that basis, then I would like to go more into the theoretical part and develop a new matrix for causal analysis in the climate change context, where we look more closely at these different logical fundamentals that we use in the law to make causal explanations. Now, the causal link between greenhouse gas emissions and specific extreme weather events is actually recognized in the Paris Agreement. So parties in Article 8 have acknowledged or recognized the importance of averting, minimizing, and addressing loss and damage associated with the effects of climate change including extreme weather events. So there is some support for a causal link between driving climate change through increasing greenhouse gas emissions in the atmosphere, increasing the concentrations, and the fact that this will lead to more severe, more frequent extreme weather events. And courts around the world have discussed the consequences of climate variability in general, and they have also sometimes, not all of them, accepted the notion that climate change is increasing the frequency and intensity of extreme weather events. Now, in the following, I will go through a few of these cases just to give you some of the context, and I will go through different jurisdictions as well. Now, is climate litigation then a success story? That's too early to state at this point. I will come back to that point. Now, one of the main obstacles for claimants is to establish causation, and that often is already a problem for the admissibility of the case, as Freddie has very rightly indicated already. Now, this general link between increasing greenhouse gas emissions and the second factor, the global mean temperature increase, and a general increase in intensity and frequency of climate change impacts. So this is between the first three factors that constitute our causal chain problem, is often well recognized by courts, but it is far more difficult to establish causation between a concrete climate impact and specific emitters, as Professor Stevens has said in his introduction. And this is where we will look at in this new causal matrix. And the reason that this is so difficult has to do with the fact that across most jurisdictions, we are using relatively mechanistic and strict tests for but-for and conditio sine qua non in the civil law tradition. So, but for this event, but for this factor, the event would not have happened. And I will go through these tests and how they are applied in more detail later. Now, even cases that were in the outcome not in favor for claimants or for the application, led courts to state or to make significant statements about a causal link between emissions and the impacts that these emissions have, and also to make statements about thresholds of significance. So there's mostly an agreement that not every single contribution to climate change, maybe if it's not even possible to detect this single contribution, can be a causal factor, but that there is certainly a contribution that is above a certain threshold that can be measured, that can then be significant. And if this can be quantified, then some courts have held that this is then, that it is possible in the law to trace this as this significant contribution as a cause. So even in Juliana and the United States, this was the case. A more recent decision from this year is Notre Affaire à tous, where the court as well held that there is a direct causal link between increasing emissions and the ecological impact and the ecological damage that these increasing emissions have for the climate, but also more widely for protection of ecosystems. Now, in this case, the Paris Administrative Court applied a tort law provision of the French Civil Code in the relationship with the state and said that the greenhouse gas emissions that exceeded the threshold of a 40% reduction were in fact against the provision where everyone who is who contributes to an ecological damage is responsible to repair this damage. And now the French state has to develop a plan to address the issue that it has, through additional greenhouse gas emissions, violated this provision and led to ecological damage. And now, very interestingly, the Committee on the Rights of the Child, under the Convention on the Rights of the Child, has held that transboundary harm that originates in one country and can be directly linked to certain emitters in that country can be foreseeable harm, and that children that are place in other countries fall within the jurisdiction of the state that is causing this harm, that the harm is also significant, which is only more than detectable, but less than serious or substantial. Again, this ties in with what I just said before, if the contribution is measurable and quantifiable. So as long as this contribution can be measured by factual and objective standards, then it stands not in the way of finding a causal link between the emissions that lead to further climate change in one country and affect children that are not in that country directly, but placed in other countries. And so here the committee held that the causal link existed between the transboundary harm and the state on whose territory the emission originated. It was then a question of not having exhausted the domestic remedies that this case was not successful in its outcome. Now, this is another very famous case that was very much discussed in Germany, perhaps not as widely globally, and that might have to do with the fact that it's only partially translated into English. Now, in Neubauer against Germany, the Constitutional Court held that the current climate protection law in Germany was partially unconstitutional. And it was very interesting to see in this case here that the court said that the protection of life and physical integrity under Article 2.2 of the Basic Law encompasses the protection against impairments of constitutionally guaranteed interests caused by environmental pollution, and this includes climate change. Now, in situations where there is remaining scientific uncertainty regarding causal relationships, the court then held that there's a special duty that is imposed upon the legislator through the general objective included in the Basic Law to protect the environment and the climate for future generations, that then this uncertainty cannot withhold the state to act, because there is this duty to act on behalf of future generations as well. So if there is any doubt, action must follow, because it is so important for the protection of future generations as well. Now, this case is very interesting because it has used what Friederike mentioned in her talk, and that is the IPCC science extensively. What we've seen here in this case is using the carbon budget approach of the IPCC, calculating then the national carbon budget and applying it in the light of constitutional doctrine. And the court has also extended and developed constitutional doctrine in a way that it hasn't done before. So it has developed a new constitutional concept of the advanced interference-like effect of climate targets. I can say more about this, but it's a complicated case, but it's really interesting to see how this court has creatively used the law and developed the law in the light of climate science. Even if it has now not used the latest attribution science, this has still framed the discussion in the Senate that made the decision. Now, this is, of course, a case that you are very familiar with, Gloucester Resources, a case now that goes away from this state as the defendant. It's an individual planning permission or private actor case, where the question was then whether the future greenhouse gas emissions that would result if there would be an open coal mine, or the permission to build this mine would go ahead, if these additional greenhouse gas emissions would contribute to further climate change. And very famously, and I think very significantly for future decisions made by the Independent Planning Commission here, Justice Brian Preston held that the project's cumulative greenhouse gas emissions will contribute to the global total of greenhouse gas concentrations. Now, what we see here is this link between future greenhouse gas emissions being recognized as being a causal factor for further climate change consequences. So again, between these first three factors of our causal chain, a good understanding and an affirmation of the existence of a causal link here. Now, in another case against and that's the last one before I come to the second part of my talk, is this case that is very famous already, Mille Defensi against the Royal Dutch Shell, where the court again found a causal link between greenhouse gas emissions and dangerous climate change. And in addition, also it found a causal link between limitation of fossil fuel production and emission reduction. And I think this is really important because it addresses the argument that is often made that if this infrastructure project doesn't go ahead, there will be another infrastructure project, and that perhaps will even increase greenhouse gas emissions globally, because then there needs to be an additional transport, and it will just be a case of replacing one bad project with another one. And that is not true. According to the court here, the district court in the Netherlands in The Hague held that studies using elasticities from economics literature have shown that for oil, each barrel left undeveloped in one region will lead to 0.2 to 0.6 barrels not consumed globally over the longer term. So in other words, not allowing to proceed with one project will lead to less consumption and therefore less greenhouse gas emissions. Now, what is then the potential of attribution science for the legal concepts of causation and attribution? As we've seen, what is missing in courts is it's often that they don't have the latest scientific evidence presented to them, but also that they're not prepared to go this final step in saying we can attribute a concrete and specific climate change impact to a certain emitter, despite the knowledge on the causal chain factors that were just discussed. Now, attribution and detection science, however, can deliver the evidence to satisfy the legal criteria of causation and attribution. And this, of course, creates the potential to change litigation outcomes. It changes the context for causal claims, and it can also improve legislation and policy frameworks. So there is always the other side of the medal. We have strategic climate litigation, but then also the need to develop more effective legal frameworks, and having a better knowledge about the forecasts of future extreme weather events can also help with the development of legal frameworks. And of course, if we were to use this science more effectively, it would allow us to do what the law is supposed to do, to allocate responsibilities and to compensate those who have suffered the damage. Now, this is the case that brought this collaboration between Freddie and her colleagues and myself and my colleagues really to full fruition. This was the case of LIA and RWE, the biggest German energy provider, and this case is still pending in the Higher Court of Appeal in Hamm in Germany. Now, as you can see, this glacial lake here in the Andes is at the center of the case, and there's a flood risk that stems from the fact that if there's a bigger ice slab breaking into the lake, there could be a huge flood wave that would then create devastation for the city of Huaraz that is just situated below this glacial lake. And this natural moraine that you can see will, in such a case, no longer be stable enough to hold the water pressure, and also the pipes that are visible here will not be sufficient to ease the water pressure in such circumstances. Now, the claim was made firstly in the first instance in the Essen court, and the claimants asked for a pro rata contribution to adaptation measures here to increase, to decrease the water pressure, increase the likelihood that this moraine will then be able to withhold the water pressure, to hold the water in the lake. But the court found that the contributions of RWE to climate change were only one amongst so many. So this situation would have arisen even without the contribution of RWE. So in applying a very rigid version of the but-for or conditio sine qua non test, the court could not find that RWE's emission were causal, even though historically RWE is among the main, the carbon majors listed in this famous report of Heder. And also there are attribution studies available that can link this increase in the risk of flooding to the emissions from a specific emitter. Now, what we see here is that there was no coherent concept of a causal explanation applicable in the absence then of normative parameters. So sometimes in those circumstances, in tort litigation or nuisance litigation, what courts have done is they have applied certain normative parameters to soften the outcome of a very harsh causal analysis, for example, in medical exposure cases. Now, in climate change, we don't have these kind of normative parameters. So we thought the only way to change our causal analysis is to delve a little bit deeper into these logical fundamentals upon which our causal analysis in the law rests. And this will be especially important for claims against carbon majors, against private actors, because as we have seen, some cases against governments or human rights litigation, the causal link is important, but it's not important in terms of linking a specific event to a certain emitter. That is not the center of the argument, whereas this becomes very crucial for the situation that we have just looked at. Now, as I said, there are these two ways of remedying the harshness of the causal analysis. And we have claimed in this work that we've undertaken since 2016 and 17 is that we have to reassess these logical fundamentals to come up with a more coherent concept of causation, because we don't have the certainty on normative correctives. Is also something that is important to work on. But we also claim that this more coherent concept is in fact sometimes already applied in some other circumstances. And if it is applied more widely, it will also address some of the other unfairnesses that can arise if this is just applied on a case-by-case basis, in terms of applying fairness in case-by-case basis. Now, what are the elements of the new causal matrix? We've looked at some of these already in the first part of this presentation. We've got E as the quantity of emitted greenhouse gas emissions. We've got T as the increase of global mean surface temperature. We've got IF, and these are the impacts of a changing climate, consisting of a general tendency of increasing frequency and severity of some weather events and climate-related slow onset events. We call this distinctive causal field. Now, this could be all heat waves in Europe or in Northern Europe, or all heat waves or bushfires in Australia. This could be extreme events that have a certain similarity and where we have certain scientific evidence for this similarity and also for the causal link between E and IF. And this is important because a single analysis or a specific analysis of a specific event that has also some similarity can then be made in the context of this distinctive field. So if we don't have all the data for a certain heat wave, we know that this is similar to the heat wave that lasted the same amount of days in the last year. We can assume that there will be similar factors that have caused it. And that, of course, gives some context for the causal analysis in the law, could even lead to a reversal of the onus of proof. Now, IS is then the occurrence of a concrete climate change impact, either a severe weather event or a slow onset event. So these are the four factors. Now, to then analyze how these are interlinked, these factors, whether they are a cause or not, Friedy introduced the counterfactual approach in the sciences, and this is actually what we are doing in law as well. We eliminate the factor and ask, in the counterfactual approach, would they still lead to the same outcome? And this logical analysis is based, or we use the elemental or the fundamentals of necessity and sufficiency. We ask, is the condition a necessary or sufficient condition to lead to this certain outcome? And there was a very groundbreaking book written by Judea Pearl on causality, which has revolutionized the understanding of causation across different scientific fields. And he introduced the element of sustenance that measures the capacity of the cause to protect or maintain the effect of a certain factor under structural changes in the model. So behind this is a mathematical formula. We've set this out in an article that was published in 2020. Now, this is the third logical fundamental that courts have already sometimes applied without maybe acknowledging it in that way, but it is possible to, with this factor, trace the increase in the probability of a risk, the increase in intensity and frequency, and also the fact that sometimes, and very often, as Freddie said, climate change is only one among other conditions that lead to certain extreme weather events. So even though something might not be a cause, or climate change will not be a cause, but for it will still be a cause if we include sustenance as a logical fundamental. Now, and with this, I'm coming to the end of the presentation. It doesn't get more complicated than this last slide, or one of the last slides. So we are using here 3 pillars to visualize or to dissect these different steps in the process of identifying the cause. So between E and T and IF, and these are the emissions and the temperature increase and the causal or the distinctive causal field, we normally use necessity and sufficiency. And if we know that there is a strong legal connection between E and T and IF, then there is also a strong legal connection between these factors, E and IF. And that is, again, something that has to do with formal logic. We're using here the transitivity theory, because if from A follows B and from B follows C, then we can also say that from A follows C. So this is, again, true for our factors that contribute to climate change. Now, as I said, we had done in the second pillar, we introduced the notion of a distinctive causal field to describe this strong link between E and IF, between the emissions and where we have certainty about certain severe extreme weather events and their intensity and frequency. But then attribution science is able to provide us the evidence to find a link between the emissions and IS. Sometimes via T, but sometimes even without going through this temperature increase. So directly finding a link between E and IS. But very often this is only possible if we allow to say that climate change, or E here, has contributed as one factor of a set of conditions that together lead to the outcome, to these extreme weather events. So for this final third pillar, we use sustenance as an additional logical fundamental, and we link it with probabilistic event attribution to explain these links and to trace the science and make full use of the science in the law. Now, you asked in your outline for this presentation a question: can climate litigation save the planet? I think that a complex challenge requires multi-factor contributions to the solution, and climate litigation, and especially strategic litigation, is one of these. But there are also the UNFCCC processes, legislation, and this all contributes to framing the discourse on climate change, to steering the action agenda, and defining its urgency. And I think the law is challenged through the science, through climate change, but it can opt to facilitate change in accordance with the scientific evidence. It's a chance for the law to be part of the change that needs to happen. And I think legal concepts, as we've just seen for causation in the climate change context, can enable or prevent climate protection. It depends on how we allow them to be applied. Now, final conclusions. As we've seen here, the Paris Agreement acknowledges some aspects of the causal chain between ET and IF in Article 8. Now, courts have found the causal link between emissions and emission-intensive infrastructure projects and climate change impacts. And courts find it challenging to establish this causal chain or to attribute an individual emitter to quantity of emissions in a certain region to specific climate impact. So this is the final link between E and IS. But this new causal matrix addresses this issue and allows for coherent explanation in the climate change context and beyond, and it captures this probabilistic increase in risk. Now, thank you very much, and I'm looking forward to your questions. Thank you.
Dr. Minnerop, thank you so very kindly for that presentation. Absolutely fascinating. As I indicated in my introductory remarks, I've been working in this space for some time and have read the work of Miles Allen and others. And it is just so promising to see the work of the climate science community being connected with the law in such a sophisticated way. The logical framework you set out, this causal matrix, although very complex, nonetheless provides a promising way forward. And having worked in a court for a judge and having seen firsthand litigation, I can say with some certainty that judges would relish the opportunity to deal with some of these logical dilemmas and issues around causation. Causation is a really bread and butter issue for courts, whether it's in the civil law tradition or the common law tradition. So yeah, I can see you're making an extremely valuable contribution to this space, and it's going to be exciting. And I think, you know, the floodgates are opening when it comes to climate litigation, and we're going to see a lot of the work that you're doing, I think, having a practical impact on real world decisions. So wonderful. Thank you so much. Absolutely spectacular, Petra. So the question that we had in the chat from Morgan, I suspect you may have already addressed, because the question was really how lawyers can use the facts around climate attribution to prove causality or causation. I think you've probably addressed that question pretty comprehensively in your presentation. Morgan then had a follow-up question, interesting question. Perhaps I can put this to you, Petra, and perhaps I'll put it this way. To what extent have theories of causation as used by courts in other fields of law, so not necessarily torts or nuisance, say in crime and in other areas, to what extent are they relevant or can impact on the way we deal with causation in a climate case?
Yeah, thank you very much. That's a brilliant question. I think what we see as a general tendency between courts, that they take into account what other courts have said, especially when they go against their own governments as a defendant. So there is an interjurisdictional, interjudicial discourse taking place. So there's a reasoning taken on board from other courts, perhaps not so much from other fields of litigation. I think what happens here is mostly that we look at causation as a concept in the law in a specific jurisdiction. So if in a civil law jurisdiction, causation will mean the same or should be the same for different kinds of litigation. So even though, for example, under the German civil code, this case on Lilia centers around a provision in nuisance law, that is not a tort law provision, but indirectly causation from tort law comes in through the requirements that need to be satisfied for the nuisance causal test, so to speak. But what we have seen, or what we could see even more perhaps, is that courts take into account outcomes of research that look into tobacco litigation, for example. What happened there, and how has legislation then perhaps helped in the next step to overcome some of these hurdles to causation in terms of applying a market share approach for the contributions that then tobacco companies have made to the overall issue, or the health consequences from using tobacco products. So this is something that we could see more in courts, but I think that is probably something that needs to be taken up through research more, where we say this has happened here, why is the situation now here so different? And our claim, or our construct, is based on the observation that courts in many other instances have softened these rigid analysis. In asbestos litigation, the but-for test, for example, was never satisfied. There was never certainty that could say that, or we could never say with certainty that a certain employer had violated a duty of care towards the employee, and therefore he suffered the harm that he has suffered. So there was then, because of that, and in applying normative correctives, the courts have then said, well, in this circumstance, everyone will be jointly and severally liable for the damage that they have caused. So this is, of course, something that has indirectly influenced us in our analysis, in saying we can find something that allows for a more coherent outcome through changing or extending the logical fundamentals, and it will lead to the same outcome in these cases as well then. So it is possible through the research to make these connections, but it's less a case of that we see this already happening in the courts.
Just while we're waiting for others to pop questions in the chat, maybe I can just ask a follow-up, Petra, specifically on that softening of the harshness of causation tests via legislation, specifically in the asbestos context, but also, I guess, in the tobacco context as well. I wonder whether we might see legislative reform when it comes to environmental damage, or do you think that would be a bridge too far? I guess when it comes to asbestos harm, it involved significant impacts on individuals, but also a society level impact in terms of health costs, and governments essentially decided they didn't want to pay for that, so they wanted some system of liability so that the asbestos companies would pay for it. I wonder whether the same imperative will necessarily apply in the climate context, but perhaps it will. Interested in your thoughts about that.
Ideally, it would. I absolutely agree with it. I mean, if there would be such a change in the law, that would be very much appreciated. I mean, there could be other changes that would be possible, like the reversal of the onus of proof, for example. If we know that there is a certain situation that is very similar to one where we had all the data, because often what we find is there isn't the sufficient data available to make a very well substantiated claim. So in those circumstances, one could say, well, if then we know this is a similar event, why can't we then use the distinctive causal field and say, well, the other side has to prove that this is very different, or maybe have some, some adjustments in the allocation, in the standard of the proof that is required. But I think what is crucial to, or maybe a more likely step that could be taken is, as this came up in the Paris Administrative Court as well, is if you have as a state certain thresholds and defined amounts of substances, that whether this is now emissions or air pollution substances, I think it is then possible for courts to hold state and state authorities to account if they then disregard or don't comply with these thresholds. We've seen this with a very recent case in the UK, actually close to a landfill site, where a young boy was suffering breathing problems, and the court went through the entire case law of the European Court of Human Rights and said that here the duties under Article 2 and 8 of the ECHR were triggered, and the authority had not discharged their duties because they had allowed higher levels of these pollutants to be emitted. And I think if we had something similar for climate change, where we can say these are the sectorial targets and they need to be complied with, and if they're not complied with, then these exceedingly high emissions will be either an ecological damage, or they will certainly trigger some sort of responsibility because of non-compliance with the duty of care. I think that would be a great progress. So legal targets are absolutely crucial.
Now, we've had a host of really terrific questions that have just come in. First question from RVR, and the question really goes to who would be the best plaintiffs and the best defendants in these kinds of cases, I guess. I'm just wondering whether I guess that's really a strategic issue around the best way to run this kind of litigation.
Can you just remind me, which kind of litigation do you mean?
So, so the kind of well, who are we going after, I guess, or who are plaintiffs going after in these kinds of cases? Are they going after the carbon majors? Are they going after governments? Perhaps does the causation issue change depending on who the plaintiff is and who the respondent is?
Yes, so I think we had this discussion actually at a conference where we had half scientists and half lawyers, and the scientists were accusing the lawyers of bringing the cases in the wrong places, simply because cases are often brought where the science is very thin, and then that leads to a misrepresentation of the science for the diffuser argument in court, and simply for the general statement then that no causation and no link could be found. So I think it is crucial to really be guided by the scientific studies and to understand where's the strong science, where do we have attribution studies, and then bring a case or trying to bring a case in those jurisdictions. And then some legal frameworks in some jurisdictions don't really allow for certain actions that are possible in others. I mean, this case, LIA and RWE, it originates in a provision that was construed as a neighborhood nuisance claim. It was about, the 1004 of the Civil Code is a provision that says if your apple trees branches are hanging over my property, I can change that. I can request you to take them to take that away, and if you don't do it, I can do it at your cost. So it's this kind of nuisance where one is the disturber and the other one is entitled to ask for the disturbance to be removed. And the fact that this is applicable in the relation with the biggest German energy provider and this farmer claiming from the Andes, I think that's quite extraordinary. But this is actually probably at the moment the only case where we can really say there is a strong study of the climate science of attribution studies, and it would be interesting to see what the outcomes are in this case. There's an in-country visit planned now in Peru for the court to see the scene and to see what the facts are. So I think this the choice of defendants and the choice of jurisdiction has to go hand in hand with the availability of the science. And a promising route is certainly in the wake now, certainly of COP26, but perhaps also before, the requirement of states to develop NDCs and long-term strategies that are in line with the NDCs and the legislation to achieve these NDCs and long-term strategies should give new opportunities for claimants to ask for either more stringent targets, as we've seen in New Zealand, in the Netherlands, of course, but now also in Germany, for example, and to then bring claims in that context. This case in Germany has led to many different cases starting now in the federal states, so in North Rhine-Westphalia, in Saxon, in Bavaria. So we've seen now different cases being brought to court because the states have not fulfilled the obligation to have a law. So I think this is something that is very crucial to see, that one case can lead to these further cases springing up, coming out of the ground, because some new development in constitutional doctrine makes it possible to bring those cases as well.
Well, I think a question that works well as a follow-up is from Warwick, who is really asking to what extent we are confident that the judiciary in Germany or elsewhere is going to be able to adopt new approaches to deal with causation in climate cases.
That's again an actually excellent question, and almost one where I would need to have a crystal ball. I think the entire context for climate litigation is changing, and it only needs a few of these landmark decisions where judges have been certainly very brave in some aspects to say we can use the law, and this outcome can't be right. So we have to use the law in a way that it is not against the wording of the law. I'm not going against any positivist doctrine here, but to say how can we apply the law in the way that we use the science that we have. Whether other judges will follow suit really depends on so many different factors that it is very difficult to foresee. Or to speak for all jurisdictions.
Very good. Now, there's a few other questions. There's a question from Cameron Petra. I'm not sure whether you are familiar with the Sharma case in the Australian context, where an Australian court found that the Minister for the Environment was under a duty of care to take into consideration the effects of climate change on young people. If you are aware of that judgment, the questioner is asking whether or not you think that kind of duty of care conclusion is going to become prevalent in other legal systems around the world, and to what extent that duty of care type argument has got up in other courts.
Yeah, it's a brilliant question. I think this duty of care argument has actually already been used far more in the more recent years. And interestingly as well, it has aligned duty of care of private actors with the duty of care of states. If you take the case of Mille Defensi, what we've seen here is that the court has aligned the duty of care of Shell with the duty of care of the state to achieve 45% of emission reductions in line with the IPCC findings by 2030. So this is something that of course applies first and foremost to the state as being responsible for developing the legal frameworks. Now, in the European context of for those states that are part of the Council of Europe, where the ECHR is applicable, the duty of care argument is a very strong one. And we've now seen 4 cases are pending at the ECTHR at the moment. And they look into exactly this, the duty of care under Article 2 and under Article 8. So the obligation to act and to do more than states are currently doing. And so I think this alignment of duty of care of private actors and state actors, but also the duty of care that arises under human rights instruments is something that will be really interesting to watch how this develops.
And I guess causation tends to be less of a central issue than in the liability cases. It can be dealt with in a more straightforward way. Well, we're almost at time, and I propose that we now wrap up the proceedings. So on behalf of the co-directors of the Australian Centre for Climate and Environmental Law, my dear colleagues, Professor Rosemary Lister and Associate Professor Ed Cousins, I want to extend my sincere thanks both to Freddie and to Petra for really wonderful presentations, really bringing us up to speed on a truly groundbreaking and exciting area of law and of science. It may not save the world, but I think, as Petra explained, it is, you know, one part of the solution. We need to be looking at all possible options to get governments and companies to be cutting emissions and to compensate the victims of climate change. So I'm going to close the proceedings with those thanks. The webinar has been recorded, so you're going to be able to flick back through the slides and to hear the presentations once again. And yeah, I just thank everyone as well who's managed to dial into this Zoom late in the evening, Sydney time, very early in the morning in the United Kingdom. I can hear there's some action behind Petra. The household is starting to move and wanting to get off to school and work. So thank you, Petra, for joining us at such a challenging time of the morning. So thanks, everyone. Thanks for joining this final event for ACCEL for 2021. And we look forward to seeing you in the new year. Goodbye, everyone.
Thank you.